Hello, my students, and welcome to this session. In this session, we are going to have a look at the rules of powers. And before we start, I want to show you the meaning of the power. If I said to you 2 raised to the power of 3, what does it mean? 2 raised to the power of 3 means 2 multiplied by itself 3 times. 2 is called the base, and 3 is called the power. And 2 times 2 times 2 equals 8. And if I have x, any number, raised to the power of 5, that means this number is multiplied by itself 5 times. It's x multiplied by x, x multiplied by x, multiplied by x, multiplied by x, multiplied by x 5 times. Okay? And if I have a fraction, like this fraction 2 over 3, all raised to the power of 2, that means this base, which is 2 over 3, the numerator and the denominator, raised to the power of 2. So it's 2 over 3 multiplied by itself 2 times, which is going to be 4 over 9. So if we have something like 5 times 5 times 5, it's 5 multiplied by itself 3 times. All of us know that 5 multiplied by itself 3 times equals 125. But if I want to write it as a number raised to the power, so I can write it as 5 raised to the power of 3. 5 is the base, and 3 is the power. Okay? And 5 raised to the power of 3 equals 125, as you know. What about 5 raised to the power of 2? 5 raised to the power of 2 means 5 multiplied by itself 2 times, which is 25. And what is the meaning of 5 to the power of 1? 5 raised to the power of 1 means it's only 1 5. Now we have a sequence. 5 raised to the power of 3 is 125. 5 raised to the power of 2 is 25. And 5 raised to the power of 1 is 5. If we looked at the powers here, we have 3, and then we have 2, and then we have 1. Look at the result here. We have 125, and then we have 25. What is happening? We divided by 5. We divided 125 by 5 to get 25. And 5 to the power of 1 is 5. And if we looked at 5 to the power of 2 is 25, and 5 to the power of 1 is 5, also we divided by 5. What about 5 to the power of 0? 5 to the power of 0, we will follow the same sequence. We will divide it by 5. So 5 to the power of 0, 5 divided by 5 equals 1. Now I want to explain why 3 raised to the power of 0 equals 1. This is the question. I'm going to discuss it with you now. So let's start by 3 to the power of 4. 3 to the power of 4 means 3 multiplied by itself 4 times equals 81. 3 to the power of 3. 3 to the power of 3, it's 3 multiplied by itself 3 times. So 3 times 3 times 3 equals 27. What about 3 to the power of 2? 3 to the power of 2 equals 3 multiplied by 3, which is 9. Then 3 to the power of 1 equals 3 only. Now look at the powers here. We have power of 4, and then we have 3. The power is decreased by 1 each time. So look at the pattern of the powers here. We have 4, we have 3, we have 2, we have 1. Look at 3 to the power of 4. 3 to the power of 4 equals 81. And 3 to the power of 3 is 27. And 3 to the power of 2 equals 9. So each time we decrease the power by 1, we divide here the result by 3. And 81 divided by 3 equals 27. And when dividing 27 by 3, it's 9. And if you want to get 3 to the power of 1 here, okay, we will follow the same pattern. We will divide 9 by 3. So 9 divided by 3 equals 3. Now we can find 3 to the power of 0. We will follow the same pattern. 3 to the power of 0. We'll divide here the 3 by 3, and 3 divided by 3 equals 1. And if you tried any number following the same way, you will get 1. If you want to find like 6 to the power of 0 equals 1. And 8 to the power of 0 equals 1. We can follow the same pattern to deduce that each number raised to the power of 0 equals 1. So any number, any value, x to the power of 0, okay, equals 1, such that x is not equal to 0. So x can be any number except 0. So any number raised to the power of 0 is 1. And also if we have a fraction like 3/8, all raised to the power of 0, also it will be 1. And if you have a negative number like -8/11 raised to the power of 0 equals 1. That's it. Now we will discuss together multiplying like bases. So let's write 5 to the power of 3, and then we are going to multiply it by 5 to the power of 4. You know, what is the meaning of 5 to the power of 3? 5 raised to the power of 3 is 5 multiplied by itself 3 times, okay? Because the 5 to the power of 3 means 5 multiplied by itself 3 times. 5 raised to the power of 4. You know, 5 raised to the power of 4 means it's not 5 times 4, but it's 5 multiplied by itself 4 times here. Instead of that, instead of writing 5 multiplied by itself 3 times, then multiplied by 5 multiplied by itself 4 times, we have here 7 5s multiplied by each other. So we can write, instead of that, we can write it as 5 raised to the power of 7. I don't care about the value of 5 raised to the power of 7, but 5 multiplied by itself 7 times, we can write instead of that, to save a lot of time and to save a lot of writing. We can write it directly. It's 5 to the power of 7. So if we are multiplying like bases, look here, we have 5 to the power of 3, and here 5 to the power of 4. We will write the base as it, which is 5. Then we will add powers here. 3 plus 4. 3 plus 4 equals 7. So we ended up with 5 raised to the power of 7. So if we have x over y, all raised to the power of 3 multiplied by x over y, all raised to the power of 8. You know, we have here like bases. We have x over y. This is the base here. We deal with it as the base, this fraction. And here we have the same base, x over y. So we're going to write x over y, the base as it. Then we are going to add power. 3 plus 8 equals 11. And this power is above all fraction. So that means it's x to the power of 11 over y to the power of 11. So if we have a fraction like this one here, 3 over 8, all raised to the power of 2. That means 3 to the power of 2 divided by 8 to the power of 2. And if we have something like A over B, all raised to the power of 9, that means this A is raised to the power of 9 and this B is raised to the power of 9. And if we have a fraction like this one, 3 over 4, raised to the power of negative 2, multiplied by 3 over 4, all raised to the power of 5. We will follow the same rule because we have here like bases. The base here is 3 over 4 and the base here is 3 over 4. So we're going to write the base as it, which is 3 over 4. Then add powers. Add negative 2 to 5. This is the power here is negative 2 and the power here is 5. Add them. Negative 2 plus 5 equal 3 over 4, all raised to the power of negative 2 plus 5, it's 3. And 3 over 4, all raised to the power of 3 is going to be 3 to the power of 3 over 4 to the power of 3. 3 to the power of 3 equals 27. And 4 to the power of 3, it's 4 multiplied by itself 3 times. 4 times 4 times 4 equals 64. Okay. Now we will discuss dividing like bases. If you have something like 4 to the power of 7, all divided by 4 to the power of 5. It's the same as 4 to the power of 7 divided by 4 to the power of 5, the same meaning. So let's analyze it. We have here 4 to the power of 7. You know, 4 to the power of 7, it's 4 multiplied by itself 7 times. 1, 2, 3, 4, 5, 6, 7. Divided by 4 to the power of 5. It's 4 multiplied by itself 5 times. You write 4, 5 times. 1, 2, 3, 4, 5. Cancel 5 fours from the denominator and 5 fours from the numerator. 1, 2, 3, 4, 5 here. Okay. You ended up with 4 times 4. You know 4 times 4, it's 4. We can write it as 4 to the power of 2. You can follow a rule to find the result quickly. We have here the base is 4 and the base is 4. We have like bases here. The base and the base, they are the same. So in this case, you can save a lot of writing. We can write the base, which is 4, then subtract powers, 7 minus 5. You know 7 minus 5 leads you to get 2. So it's 4 to the power of 2. 4 to the power of 2 means 4 times 4, which is 16. Now, I want to prove that 3 to the power of negative 2 is the same as 1 over 3 to the power of 2. How can we prove it? You know, 3 to the power of negative 2, we can just take it from 3 to the power of 4, for instance, or 3 to the power of 5. You know, 3 to the power of 4 is 3 multiplied by itself 4 times. Okay, which is 81. And 3 to the power of 3, it's 3 multiplied by itself 3 times, which is 27. And 3 to the power of 2, it's 3 multiplied by itself twice, which is 9. And 3 to the power of 1, it's only 3. Look at the pattern we are following. As decreasing the power by 1 each time, we divided here the result by 3. We divide the answer by 3. Each time we divide by 3. Okay, 81 divided by 3 is 27, and 27 divided by 3 is 9. and 9 divided by 3 equals 3. And as you know that 3 to the power of 0, we will divide this 3 by 3. 3 divided by 3 equals 1. So once again, we are decreasing the power by 1 each time. So here we have 4, the power is 4, and the power is 3, and the power is 2, the power is 1, and the power is 0. What about 3 to the power of negative 1? Okay, because each time we divide here by 3, each time we divide by 3. So we will follow the same pattern here. We will divide this 1 here by 3 to get 3 to the power of negative 1. Because we reached 3 to the power of 0, and 3 to the power of 0 is 1. So 3 to the power of negative 1, you will divide this 1 by 3 because we are following the same pattern. So it will be 1 over 3. So dividing 1 by 3 leads to get 1/3. So 3 to the power of negative 1 is going to be 1 over 3. We can write 3 to the power of negative 1 as 1 over 3 to the power of 1. What about 3 to the power of negative 2? In this case, you will divide by 3 also. So 1/3 divided by 3, 1 over 3 divided by 3. Divided by 3. If you remember, keep change flip. You write 1/3, and instead of that, it will be, instead of divided, it will be 1 over 3. Keep change flip. So that is going to be 1, and 3 times 3, which is 9. So we can write 3 to the power of negative 2 as 1 over 9. 1 over 9, which is 3, we can write instead of 9, 3 to the power of 2. So look to what is happening here. I have 3 to the power of negative 2, and we deduced that 3 to the power of negative 2 is equal to 1 over 3 to the power of 2. Look at the power here. The power is negative 2. The power is negative 2. And look at the power here. It's 3 to the power of 2. So I changed the place of this 3 here. I wrote it down. And I changed the sign of the power. Instead of negative 2, I wrote 2 here. So when asking about 5 to the power of negative 3, 5 to the power of negative 3, if you follow the same pattern, you would get 1 over 5 to the power of 3. And any x raised to the power of negative 8, the power is negative, so we can write it as 1 over x to the power of 8. Okay. What if we have something like 2 raised to the power of 3, all raised to the power of 4? So where is the base? The base is 2. Here is the base is 2. And we have 2 powers here. The first power is 3, and the second power is 4. So we are going to deal with 2 to the power of 3 as a whole chunk here. And we have 2 to the power of 3, all raised to the power of 4. That is going to be 2 to the power of 3 multiplied by itself how many times? 4 times. Because any value, any quantity raised to the power of 4 means multiplied by itself 4 times. So 2 to the power of 3, all raised to the power of 4, because we have here power of 4. Okay. So that means this quantity here, whatever this quantity is, we will multiply it by itself 4 times. 1, 2, 3, 4 times. And you know that 2 to the power of 3 is 2 multiplied by itself how many times? 3 times. And 2 to the power of 3, this one is 2 multiplied by itself 3 times, and this 2 is multiplied by itself 3 times here, and this 2 is multiplied by itself 3 times. So write 2 times 2 times 2 here, and 2 to the power of 3 here is 2 times 2 times 2. And here we have 2 to the power of 3, the same, 2 multiplied by itself 3 times. And here 2 to the power of 3, which is 2 multiplied by itself 3 times. And instead of that, we can save a lot of writing. And we have here, we have 12 to choose here. Okay, so write, instead of that, 2 raised to the power of 12. So we reach to a conclusion. We can find the result quicker than that. We have 2 raised to the power of 3, all raised to the power of 4. We can write the base as it. The base is 2 here. We can write the base 2. And then multiply powers. We have 3 as a power, and we have 4 as a power. So instead of that, we can multiply 3 by 4. It's going to be 12. So if I have a value like x, any value, raised to the power of 5, all raised to the power of 4. Actually, we have a base. The base is 5. So write the base as it. And then multiply the two powers here. We have 5 and 4. So multiply them. That leads to get 20. So it's x to the power of 20. Okay. So 3 over 4. All raised to the power of 4 and all raised to the power of 8. You know, in this case, we have the base, which is 3 over 4. And we have two powers here. I'm not caring about the value of 3 over 4 or raised to the power of 4 or raised to the power of 8. No, I want to just focus on the rule we have studied. So you are going to write the base as it, then multiply the two powers. 4 times 8 is going to be 32. That's it. Okay. If I asked you about, again, 8 to the power of negative 2. You know, 8 to the power of negative 2 is the same as 1 over 8 to the power of 2. I changed the place of this 8 here. The first 8 is written in the numerator at the top here. Because 8 is considered 8 over 1. So the first 8 is written at the top, and the second 8 here is written down at the bottom here, at the denominator. So I changed the place of 8. Instead of writing 8 in the top, I wrote it down at the bottom. And I changed the sign of the power. I have here negative 2, and I have here 2. I changed the sign of the power. So if we have fraction like 3 over 4, all raised to the power of negative 2, and I want to get the value of this 3 over 4 or raised to the power of 2. You know, 3 over 4 first of all, or raised to the power of 2. It's 3 to the power of 2 over 4 to the power of 2, which is 9 over 16. What about the negative power here? We will follow this rule here. You know, this is the base. This is the base. And the power is negative 2. So to get rid of the sign of the power, and write it as a positive power, So it will be 1 over, and change the place of this fraction here. It will be 1 over 3 over 4. I'm dealing with it as a whole chunk, a whole number, all raised to the power of 2. You know, that leads to get what? That leads to get 1 over. You know, 1 over means 1 divided by. So instead of write 1 over 3 over 2 to the power of 2, can write 1 divided by 3 over 4 to the power of 2. So that is going to be 1 divided by, this power is distributed on them. So it will be 1 divided by 3 to the power of 2 over 4 to the power of 2. And we have a rule we have studied before. How can we deal with division? Keep, change, flip. So write this 1 is it. And then change from divided to times. And flip 3 over 2 and 4 over 2. We are going to write it as 4 over 2, all divided by 3 to the power of 2. Okay? Instead of divided by, I wrote it as times. So keep the first value here, which is 1, change from divided to times, and flip. That leads to get, I'm not caring about the value, but I want to get a rule here just to follow. So 4 all raised to the power of 2 and 3 all raised to the power of 2. We can write it as 4 over 3 all raised to the power of 2 because they have the same power. So we reach to an important conclusion. If we have a fraction and this fraction is raised to the negative power, like this one, we can write it directly as 4 over 3 all raised to the power of 2. So if we have fraction, if you have a fraction like this one, 3 over 4 all raised to the power of negative 2, we can write it directly as 4 over 3 all raised to the power of 2. Okay, so if we have x over y to the power of negative 3, it will be equal to y over x. Switch numerator and denominator of switch them. So instead of writing x at the top, move it down to the bottom, and instead of writing y at the bottom, move it up to the top. So that is going to be y over x all raised to the power of 3. Instead of negative 3, we write 3. Okay, and that is equal to y to the power of 3 all divided by x to the power of 3. What if I have something like this one here? B to the power of negative 1 all raised to the power of 3. You know, here we have 2 powers and we have a base. So write the base as it and multiply the powers. So negative 1 multiplied by 3 is going to be negative 3. How can we get rid of this negative power? It changed the place of the base. So we are going to move it down. It's going to be 1 over b to the power of 3. If we have something like 5x to the power of negative 1 all raised to the power of 2. You know, here we have 5, okay, and we have here x to the power of negative 1. This power here, okay, belongs to x only. And what about the power here, 2? This 2 belongs to 5 is distributed on 5 and distributed in x to the power of -1. So 5 multiplied by x to the power of -1 all raised to the power of 2 is going to be 5 to the power of 2, and x, we have here two powers here, -1 and 2. So multiply them together. It's going to be 5 to the power of -2. Okay. And 5 to the power of 2 is 25. You know, 5 times x to the power of -2. So its time is multiplied by an x to the power of -2. How can we get rid of this negative power? Move it down. So it will be 1 over x to the power of 2. Okay. So 25 times 1 is going to be 25 over x to the power of 2. If we have something like 9 to the power of 3 multiplied by 9 to the power of 4 divided by 9 to the power of 6, okay, all raised to the power of -2, okay. So in this case, we have like bases here, okay. So when multiplying like bases, right, the base is it, which is 9, and add powers. We have 3 and 4. Add 3 to 4 is going to be 7. So it's 9 to the power of 7 divided by 9 to the power of 6. Okay. All raised to the power of -2. Okay. We have here division operation. This line here means 9 to the power of 7 all divided by 9 to the power of 6. So it's going to be 9 and subtract powers here. 7 minus 6 is going to be 1. All raised to the power of -2. Actually, we have two powers. We have 1 and -2. So multiply them. 1 multiplied by -2 is going to be 9. And -1 times -2, it's -2. And at the end, how can we get rid of this negative power? Move it down. It will be 1 over 9 to the power of 2 is going to be 1 over 81. Let's have a look at this question here. We have 2a raised to the power of 5 times 2a raised to the power of -8. So they are like bases. We deal with it as a base, 2a as a base. And here's 2a as a base. So write the base as it, write 2a as it. This is the base. And when multiplying like bases, just add powers here. We have 5. This is the first power. And the second power is -8. So add 5 to -8 equals -3 here. So 2a, we deal with it as a whole chunk as the base here, raised to the power of -3. So how can we get rid of this negative power? Move the base down here. So it will be 1 over 2a all raised to the power of 3. I moved it down here. So it will be 1 over 2a all raised to the power of 3. You know, 2a all raised to the power of 3. This power is distributed on them. So it's 2 to the power of 3 multiplied by a to the power of 3. I distributed the power on them. So it will be 1 over 2 to the power of 3, it's 8. And a to the power of 3, write it as it, a to the power of 3. If I asked you about the half of 2 to the power of 20, what is the meaning of the half of a quantity? The half 2 divided by 2. So if I asked you about the half of 100, the half of 100 means 100 divided by 2, which is 50, okay? But 2 to the power of 20 without using the calculator. It's 2 to the power of 20. I want to find the half as a number raised to the power, okay? Don't use the calculator at all. So 2 to the power of 20. To find the half, so divided by 2. To find the half, divide the value by 2, and the value is 2 to the power of 20. So it will be 2 to the power of 20 divided by 2, which is 2 to the power of 1. So write 2 and subtract powers. 20 minus 1 is 19. The next, the quarter of 2 to the power of 100. What the meaning of the fourth or the quarter of 2 to the power of 100? The quarter of a value 2 divided by 4. So in this case, you will divide the value here, 2 to the power of 100 divided by 4. Actually, they are not like bases, okay? Because we have here 2 and we have here 4, okay? And why I divided by 4? Because I want to get the quarter of this value, so I divided it by 4. But we can just write this 4 as 2 to the power of 2. 4 equals 2 to the power of 2. So that is going to be 2 to the power of 100 divided by, instead of 4, write it as 2 to the power of 2. Now we can divide, because we have here like bases, 2 and 2. So write this 2 as it, write this 2 as it, then subtract powers. 100 minus 2 equals 98. I want to get the double. The double just to multiply by 2. The double of 2 to the power of 50. So the double, again, to multiply the value by 2. So 2 multiplied by 2 to the power of 50. It's 2 to the power of 1 times 2 to the power of 50. You know this 2 means 2 to the power of 1. And it's times when multiplying like bases in multiplication. When multiplying like bases, we write the base as it, then we add powers. We have 1 and 50. That is going to be 51. How can we get the half of 4 to the power of 500? You know the meaning of the half of a value to divide it by 2. So it's 4 to the power of 500 divided by 2. You know this 2 is 2 to the power of 1. If we looked at the bases, they are not the same. We have 4 and we have 2. They are not the same. We couldn't subtract powers because the bases are not the same. So I want to write the two bases to be one value. The 4 is 2 to the power of 2. So we can write instead of this 4 here. We can write instead of that. We can write instead of that 2 to the power of 2. Because 2 to the power of 2 is 4. And don't forget, we have 500 as a power. Just what I did, I wrote instead of 4, 2 to the power of 2. And that's right, 2 to the power of 2 is 4. Divided by 2 to the power of 1. When having 2 powers above a value here, we can write the base as it, then multiply powers. Multiply 2 by 500. 2 times 500 is going to be 1000. So it's 2 to the power of 1000 divided by 2. You know, 2 is 2 to the power of 1. When dividing like bases, here, we have 2 as a base and we have 2 as a base. So write the base as it, then subtract powers. 1000 minus 1 is going to be 999. That's it. Let's have a look at this example here. We have 2 to the power of -8 multiplied by 2 raised to the power of -3 all divided by 2 to the power of negative 13 times 2 to the power of 3. When multiplying like bases, just ignore this power here and tied it up and try to get one value from all values written between the two brackets. So it will be 2, and when multiplying like powers, like bases, add powers. So negative 8 plus negative 3. I'm adding them, so it's negative 11 divided by, we have here 2. They are like bases, so it's 2 and 2. Write the base as it, then add powers. So negative 13 plus 3 is going to be negative 10. Okay? All raised to the power of negative 2. Leave this power now as it. And then we have like bases here. We have 2 and 2. Write the base as it. And then subtract powers. So it's negative 11, negative minus negative 10. Because when dividing like bases, we will write the base as it and subtract powers, or raise to the power of negative 2. That is going to be 2. And we have negative after negative. Negative times negative, it's a positive. So it will be negative 2 to the power of, 2 to the power of negative 11, and negative, it's a positive, plus 10. Okay, and leave this negative power here, negative 2 as it. That is going to be 2. Negative 11 plus 10. Add them, you will get negative 1. All raised to the power of negative 2. At the end, we will multiply the two powers here. We'll write the base as it and multiply negative 1 times negative 2. Negative times negative, positive, and 1 times 2, 2. So 2 raised to the power of 2 equals 2. Thanks for watching and see you in the coming episodes. Goodbye.